Hello everyone and welcome back to this calculus course. Today we are going to talk about the laws of limits, a set of rules that govern the mathematical operations in differential calculus. The laws of limits that we are going to present today are the following: the limit of a constant, the limit of addition or subtraction, and the limit of products or division of functions. The first law establishes that if we have the limit when x goes to some value for a function f of x equals c, where c is a constant, it's itself. In other words, the limit when x goes to a of c is equal c. We can easily see this on this graph, that no matter the value that we go to in the limit of a constant is always itself. The second law of limits establishes that if we have two functions, f and g, and we want to know what is the limit when x goes to a of f of x plus or minus g of x, this will be the same as getting the limit when x goes to a of f of x plus or minus the limit when x goes to a of g of x. The third rule of limits divides itself into parts. The first one establishes that if we have two functions, f and g, and we have the product of those two functions, then the limit when x goes to a of f of x times g of x is equal to the limit when x goes to a of f of x times the limit when x goes to a of g of x. As well, if we have the division of those two functions, which is the second part, then the limit when x goes to a of f of x divided by g of x will be the same as the limit when x goes to a of f of x divided by the limit of g of x when x goes to a. Now, let us put into practice all of these rules, okay? Let us consider the functions f of x equal x cubed and g of x equal x squared. And let us consider the limit when x goes to 2 of x cubed plus x squared. Now, that will be equal to the limit when x goes to 2 of x cubed plus the limit when x goes to 2 of x squared, which are 8 plus 4, which is equal to 12. Respectively, if we do the subtraction instead of the addition, the limit that we will get will be equal to 4. Now, if we do the product of those functions, the limit that we will get will be equal to 32. Finally, if we do the division of those two functions, the limit that we will get will be equal to 2. So those were the laws of limits. But let's say that you don't like following the rules so much. Don't worry, I've got you. Because you can use something that we already called the naive substitution, which consists of plugging the value of the limit into the function. For example, if we had the functions f of x equal x cubed and the function g of x equal x squared, then the limit when x goes to 2 of x cubed plus x squared is simply 2 cubed plus 2 squared, which is 8 plus 4, which is finally 12, which is actually what we got in the first place. Now, the reason why we call this the naive substitution is because it is naive to assume that the limit is about plugging the value into the function instead of knowing what happens close to the value of tendency. Let's do one more limit, okay? Let us consider the limit when x goes to minus 1 of x squared plus 2x plus 1 divided by x plus 1. If we do the naive substitution, we get 0 over 0. Oh my god, I don't know what happened, guys, but I think we're gonna leave it like this. But in the meantime, please don't break the law.